Good day, everyone. My name is Andy Ramdeen, and today I will be doing a presentation on technology, concepts, protocols. Overview of what will be covered in this presentation is the layered architecture concept, the open system interconnect model, also known as USI model, the transmission control protocol slash internet protocol, also known as TCP/IP, and other TCP/IP protocols. So, what is a protocol? A protocol is a standard set of rules that determine how computers communicate with each other across networks. When computers communicate with one another, they exchange a series of messages. A protocol describes the format that a message must take and the way in which computers must exchange messages. Protocols enable different types of computers such as Macintosh, PC, Unix, and so on to communicate in spite of their differences. They communicate by describing a standard format and communication method by adhering to a layered architecture model. The layered architecture concept is a conceptual blueprint of how communication should take place. It divides a communication process into logical groups called layers. We'll learn more about this when I'm going through the OSI model. There are many reasons as to why you would use this concept, such as it clarifies the general functions of a communication process rather than focusing on the specifics on how to do it. It breaks down complex networking processes into more manageable sublayers. It uses industry standard interfaces that enables interoperability. That means different machines being able to communicate with one another. To change features of one layer without changing all of the programming code in every layer. As it breaks down the different layers, you could change codes in the individual layers rather than having to redo the whole code for all the layers. And it enables easier troubleshooting as it's industry standards. You know what to check for in each machine. Anytime there's a problem, you know there's steps to take because it's all supposed to follow that certain standard. Systems Interconnect Model, also known as USI model, which was created in the early 1980s by the ISO International Standards Organization. It is a reference model that describes how data and network information is communicated from one computer through a network media to another computer. The OSI reference model breaks this approach into 7 distinct layers. Layering divides a problem into functional groups that permit easier understanding of each piece of the problem. Each layer has a unique set of properties and directly interacts with its adjacent layers. The OSI model was expected to become the standard, yet it did not prevail over the TCP/IP, which we'll go on to after. And actually, in some cases, they have been joined, both models, OSI and TCP/IP, have been joined at the application layer to obtain the benefits of each. The OSI models have 7 layers, which we'll go into right now. As mentioned before, the OSI model has 7 layers. On layer 7, the application layer, it deals with the communication aspects of an application. This is the highest layer, and it is the interface to the user. Some application layer applications would be the World Wide Web and file transfer protocol. Layer 6 is a presentation layer. This functions as a translator, and it has tasks such as data decompression, data compression, encryption, and decryption. It defines how the applications can enter a network. Um, the standards that you will deal with in this layer would be like hypertext transfer protocol, tag image file format, joint photographic experts group. At layer 5 is a session layer. This makes initial contacts with other computers and sets up lines of communications. It also splits up communication sessions into 3 different phases: connection established, data transfer, and connection release. Examples of session layer protocols are network file system, structured query language, and remote procedure call. At layer 4 is the transport layer. This defines how to address the physical locations and or devices of the network and how to make connections between nodes and how to handle the networking of messages. At this layer, You deal with protocols such as transmission control protocol, user datagram protocol, and sequence packet exchange. At layer 3 is a network layer. This defines how the small packets of data are routed and relayed between the end systems on the same network or interconnected network. This layer's primary function is the job of sending packets from the source network to the destination network. Examples of network layer protocols are Internet Protocol, Open Short Path First Protocol. At layer 2, we have the data link layer. This defines the protocol that computers must follow in order to access the network for transmitting and receiving messages. Token ring and Ethernet operate within this layer. At this layer, the protocols you will deal with is address resolution protocol, serial line internet protocol, and point-to-point protocol. At the last layer, the physical layer, you have the physical connections between a computer and a network that converts bits into voltage or light impulses for transmission. It defines the electrical and mechanical aspects of the device interface to a physical transmission medium such as twisted pair, coax, or fiber. Here you deal with standard interfaces such as X21, EIA TIA 232, and EIA TIA 449, as well as high-speed serial interface. Look at this animation for an idea of how the OSI model works. So as it comes down the layers, layers 7, 6, and 5, nothing is added to it. When it reaches layers 4, though, data encapsulation takes place, which is the process of which information from one data packet is wrapped around to the data of another packet. Layer 4, 3, and 2 does this. When it reaches layers 4, though, it is known as segments. At layer 3, it's known as bucket. Layer 2, frames, and layer 1, bits. Then it goes through the network, which is the physical network, and it comes back to the receiving destination, and it goes up back the networks. When it reaches layers 2, 3, and 4, it will decapsulate what the corresponding layer on the other end of the network sent it, and pass on back the information up the layer. Without the decapsulated information, it will pass it on to the receiving layer, and that's how the OSI model works. The Transmission Control Protocol / Internet Protocol, also known as TCP/IP / IP model. This was built in the 1970s by the Department of Defense to support the construction of the Internet. The Internet is based on the TCP/IP. It is somewhat similar to the OSI model, but it defines 4 layers instead of 7. 4 layers of this model are the application layer, which consists of applications and processes that use the network. Next is the host-to-host transport layer, or just known as the transport layer, which provides end-to-end data delivery service to the application layer. After that is the internet layer. This defines the IP datagram and handles the routing of data across networks. And at the bottom is the network access or link layer, which consists of routines for accessing physical networks and the electrical connection. Now we look at the host-to-host transport layer protocols. There are 2. One is the transmission transfer protocol. This provides a full duplex connection-oriented reliable virtual circuit. Incoming TCP packets are sequenced to match original transmission sequence numbers because any lost or damaged packets are transmitted. TCP is very costly in terms of network overhead and is slower than UDP, which is the other protocol. The benefits of TCP, basically what it does is an acknowledgement is sent back to the sender upon reception of the delivered segment. So when you send, let me say, send data, once the receiver receives it, it reaches their system, your computer will get a signal saying that it was sent. And if that package was if it wasn't, the data was unacknowledged, the package would be retransmitted. and segments are sequenced back in the order upon arrival at the destination. Also, a manageable data flow is maintained in order to avoid congestion, overloading, or data loss. So, no matter how the data goes, it will always come back in its original order. Basically, that's what that's saying. The other transfer protocol, host to host transport layer protocol, is UDP. UDP stands for User Datagram Protocol. It's a scaled down version of TCP. It only gives the best effort in delivery. It does not offer error connection, does not sequence packet segments, and does not care about the order in which the packet segments arrive at the destination. Thus is referred to as an unreliable protocol. The difference between TCP and UDP is TCP, it is acknowledged, UDP unacknowledged. TCP sequence, UDP unsequenced. TCP connection oriented, UDP connectionless. TCP reliable, UDP unreliable. TCP high overhead, which is slower, UDP low overhead, which is faster. Next, we'll move on to Internet Layer Protocol. First one being Internet Protocol, also known as IP. Every host on a network have a logical ID called an IP address. Why is an IP address important? Because when sending data from one host to another through a network, you need to know where it's coming from and where it's going. So the network ID is the IP address. Next up is the address resolution protocol. So the IP then needs to know the hardware address of where it's going, of where to send the packet. So the ARP, address resolution protocol, matches an IP address to an Ethernet address. The Ethernet address is also referred to as a physical address or media access control MAC address. This is hardwired into your machine. So this is a physical address, and the ARP sends out a broadcast seeking a network node that has a specific IP address and asking it to reply with its hardware address. The next layer protocol, Internet Layer Protocol, is a reverse resolution protocol. So in some cases, the reverse is required. The MAC address is known, but the IP address needs to be discovered. So what would happen is the reverse address resolution protocol sends out a packet which includes its MAC address, and a request is to be informed of the IP address that should be assigned to that MAC address. And then the server, the RARP server, would respond with the answer. Lastly is the Internet Control Protocol, Internet Control Message Protocol. This is a management protocol and messaging service provider for an IP. Its primary function is to send messages between network devices regarding the health of a network. It also informs hosts of a better route to a destination if there is no trouble with an existing route. It can also help identify problems with that route. Briefly go through other TCP IP protocols. First up is Telnet. Telnet function is terminal emulation. It enables a user on a remote client machine to access the resource of another machine. Telnet's capabilities are limited to running applications. It cannot be used for downloading files. Next is File Transfer Protocol, FTP. FTP is a protocol that facilitates file transfer between two machines. FTP is also employed to perform file tasks. It enables access for both directories and files. It can also accomplish certain types of directory operations. However, FTP cannot execute remote files as programs. Then we have the Trivial File Transfer Protocol, TFTP. TFTP is a stripped-down version of FTP. TFTP has no directory browsing abilities. It can do nothing but send and receive files. Unlike FTP, authentication does not occur, so it is insecure. Now we have NFS, Network File System. This is a protocol that supports file sharing. It enables two different types of file systems to interoperate. And we have Simple Mail Transfer Protocol, SMTP. SMTP is a protocol that we use every day to send and receive internet emails. When a message is sent, it is sent to a mail queue. The SMTP regularly checks the mail queue for messages and delivers them when they are detected. We also have the line printer daemon. LDP, along with line printer program, enables print jobs to be spooled and sent to a network's shared printers. There's also X Windows, which defines a protocol for the writing of a graphical user interface-based client and server applications. We also have SNMP, Simple Network Management Protocol. SNMP is a protocol that provides for the collection of network information by polling the devices of a network from a management station. This protocol can also notify network managers of any network events by employing agents that can send an alert called a trap to a management station. The databases of these traps are called management information bases. And lastly, we have Bootstrap protocol, also known as BootP. When a diskless workstation is powered on, it broadcasts a BootP request to a network. A BootP server hears the request, looks up the client MAC address in its boot file. If it finds appropriate entry, it responds by telling the machine in its IP address from which the file should boot. BootP is an internet layer protocol. So just to recap, this presentation contained information about protocols, the OSI model, and TCP/IP protocols. At the end of the presentation, please feel free to leave questions or comments in the comment section, and thank you all for watching.